The dimension of the vector is space V equal to Aij, and A is n by n matrix, and entries of Aij is coming from the complex field, also having the property I and jth position of the matrix is equal to negative or minus jith entry over the field R. It means we have to find the dimension of the vector field V over R, as V is defined as this set. Now first understand what is the meaning of dimension, and dimension over the field, as we change a field, then dimension of the vector space also changes. First, this is a matrix, this is a vector space V defined by square matrix and having the property Aij. It means ijth entry is equal to minus of jth entry. Also, these elements are coming from complex set or complex. So this is my V, and we have to find dimension of V over R. Dimension of V over R we have to find. Now this is the matrix, is very familiar to us. This is skew symmetric matrix. And how to define skew symmetric matrix? If so, consider 3 by 3 matrix. It is easy to understand. Suppose this is 3 by 3 matrix, A12, A11, A12, A13, and this will be 0. This is also 0 because of skew symmetric matrix. Diagonal elements are 0, and this will be negative of this one, and this will be negative of this one, and here A2, 3, and this will be negative of this one. So this is the way to define skew symmetric matrix, and these are A12, A13, A23. These are complex entries. These are complex entries. So complex entry, it means it will be look like A plus B iota type, A plus B iota type. And how many places we are free or independent? This is my first place, and this is my second, and this is my third. In generalized way, you can understand, after leaving last element of the right bottom corner, this is first entry, and we will stop at n minus 1 entry. It means if you consider n by n matrix, suppose this is n by n matrix, so these are our zeros. This is the zero or diagonal elements. So our first non-zero entry will be here, and last up to n minus 1 entry here. So 1 plus, and this summation will go up to n minus 1. These are total number of entries uh, where we are independent. It means apply the formula. First n minus 1 natural sum. So it will be n minus 1, add 1. It will be n divided by 2. Now suppose it is matrix. So this is our first non-zero entry, and this is diagonal, so this is 0. So suppose A plus B type, this entry will be A plus B type, and we are independent here. So these are our independent choice, and each independent choice or complex field, we are independent at A and B because of this question asked about over the field R. So multiply, because we are independent at two places for each complex entry, means we are independent for each complex entry. entry. So multiply this n minus 1 divided by 2 because of we are independent at two place. So it will be n minus 1 or n square minus n. Suppose this is asked about complex over complex, then we are independent at total independent choice are this one. Total independent choice are these, and we will have the dimension of this field when asked about over C or complex field, then it will be n minus 1 divided by 2, n minus 1 into n divided by 2. These are total independent choices for complex over complex, and this is over real. So answer of this question will be option C.